Hi everyone, in this lecture we are going to discuss one very basic data structure that is called stack. So let's have a quick recap. How does a stack work? Okay, so stack is a container that follows leaf order, okay, last in first out. So you can visualize stack as a container like this, in which you can add elements from the top. Okay, suppose you add a number 1, then you add another element 2, you add another element 3, you add another element 4. So this denotes the top of the stack. So you can see what element is at the top of the stack. But if you want to extract one, so you have to first extract 4, then you have to extract 3, then you have to extract 2, then you have to extract 1. Okay, so stack follows a order called last in first out. The element that was inserted in the last will be the first one to come out. So it's a LIFO type of data structure, and for that we also have the stack STL. So let's include the header file and see some of the methods that are pretty useful while working with the stack. Okay, so clearly if stack will give you an method to insert the data, so that method is called push, and it will accept the data. It will also give you a method to remove the data at the top, so this method is called pop. It also gives you a method to look what element is present at the top of the stack, so this is called top. It also gives you a method to check if the stack is empty or not, so this method is called empty. So these are the most important methods of the stack class, and we are going to see a demo of these methods now. All right, so let's see. Let's create a stack of integers s, and maybe we will add some numbers in the stack. Let's say for int I equals to 0, I less than equals to 5, I plus plus, and I can say s dot push I. And if you want to remove these numbers, you can put a loop. You can say while s is not empty, you can just pop all of these numbers. Okay, so cout s dot top, and maybe then you do s dot pop. Okay, so let's run this simple program, and we have to include this header file called stack. Okay, and we are done. Okay, so clearly you can see you inserted the numbers in this order. So numbers are going in this order: 0 1 2 3 4 5. And when you use the top function, this gives you the topmost element. It returns the topmost element, and the complexity of s dot top is order 1. S dot push also works in O1 time, and s dot pop also works in O1 time, because you just want to remove this particular element. Okay, so these are the major three operations in the stack, and there is an empty function that we are checking. While the stack is not empty, we are popping out elements. Okay, so as simple as that. And internally, if you want to implement a stack, you can use an array, you can use a vector, you can use a linked list, you can use a dynamic array. Okay, so internally it can be anything. uh, Generally people prefer to work with a vector or a dynamic array, because it allows you to grow your stack. Okay, if you use an array, you have a limit on number of elements, but if you have a vector or a dynamic array, you can easily grow the number of elements of it. Okay, linked list also can be used, because since you do not want to access the ith element. Okay, so this operation is not allowed. So you can also use linked list to build a stack class of your own. Okay, so that's all. We will see more examples in the next video.